SOA exam P practice question number 40. A computer system is newly installed at the beginning of a calendar year. The time in years before the system experiences its first failure is exponentially distributed with mean 3. Calculate the probability that the system experiences its first failure in the last quarter of some calendar year. Let's take a look at the solution. Let t be the time to the first failure since the installment, and this time is exponentially distributed with mean 3. We have the PDF of t, 1/3 times e to the power minus t over 3. And the CDF is 1 minus e to the power minus t over 3. We want to get the probability that the failure time occurs in the last quarter of some calendar year. Let's construct a time diagram. The time here is in years. In the first year, the last quarter corresponds to the time between 0.75 and 1. So we have the probability expression P of 0.75 less than t less than 1. And then in the second year, the last quarter corresponds to the time between 1.75 and 2. Include this probability. And then in the third year, the last quarter from the time 2.75 to 3, include this probability, and so on. We write this in terms of the CDF. The first term, we have f1 minus f of 0.75. And then the second term, we have f of 2 minus f of 1.75, and then so on. Let's calculate the first term, f1. Plug in 1 for t in the CDF expression, we get 1 minus e to the power minus 1/3. And then f of 0.75, we get this expression. So f1 minus f of 0.75, we get e to the power minus 0.75 over 3 minus e to the power minus 1/3. And then the second term, the third term. And doing some algebraic manipulation, we get to this expression. And there is a common factor in each term, which is e to the power 0.25 over 3 minus 1. Factor that out. And then in this last expression, the second term, this is an infinite geometric series where a is e to the power minus 1/3 and r is also equals e to the power minus 1/3. The second term can be rewritten as a over 1 minus r together with the first term. And upon calculation, we get the desired probability. The answer is 0.2197.